Right. Take your seats, please, ladies and gentlemen.
Okay.
Oh, so, now, second session.
Yep.
We have the Marquis to Geek. I feel I should be, like, twirling a moustache here and maybe waving a saber or something, but...
Hello. My name is Marcus. Yes, okay.
But anyway, so Steve is going to talk about, like, the original promise of WebRTC was that we were going to be able to build Skype in our browsers in an afternoon. And that's what we're going to see.
Yeah, we will. Thank you, Tim. So, as this part of the slide says, my name is Steve, and as this part of the slide says, I'm a little bit of a geek. And if we're all in the right room, I'm going to be building Skype almost literally in the browser in the course of this session. Now, in the best interest of Blue Peter, I have prepared one earlier, and the code I show you on the slides is the code I shall show you in the browser, which is the code we'll actually be running. So it better work. I have slaughtered a tofu-flavored goat in honor of the gods of the live demo. So over the course of the session, I'll be talking through the WebRTC flow. What is it that actually happens that makes a video appear from this screen over onto that screen? The connections that you need to make in order for this API to do all this magic stuff, and finally some other functionality within WebRTC that enables you to fulfill the rest of the stuff around a video call. Stuff like chat and things like that. So to start with, the flow. Basic process, the first part is we need to access that media. This isn't technically WebRTC, this is just standard HTML. It's about getting the video or getting the microphone signal. You then prepare up WebRTC. The browsers agree on what they're going to communicate. Is it audio, is it video, is it both? How they'll communicate it. Are they on a local network? Are they on two different networks? Are they behind firewalls, for example? And then once all that's been set up, the media streams just flow and magic happens. Theory, practice, let's discuss. So the first bit, access the local media. This is your standard call, get user media, and that just works. The following parameters are what's known as constraints. You see this term used a lot, that's just the Ponzi word for parameters. In this case, we are saying I would like some video and I would like some audio. Now this isn't the limit of what parameters are available to you. You can say, yes, I would like, to your webcam, for example, on the Mac, yes, I would like video, but only if you can give me a video stream that is at least 640x480, or at least 1024 by 768. Or you could, and the reason for this is because you want a video stream that's high enough definition to describe the thing you're trying to do. So if you were on an insurance site, for example, and they said, well, show us the damage to your car, and you would have to hold up your webcam or your phone camera to the damage, they would want a good high-resolution image to prove that it really was damaged. So the constraints can say, I want it to be a nice, large, high-resolution image. Or the constraint could say, I would like an image, but it better be small because I'm on a pretty low bandwidth and I'm not really that fast. So the constraints let you set all these parameters up ahead of time, so when you call get user media, it returns you a video stream of something suitable for your purpose. You then prepare WebRTC. This all comes down to the thing called peer connection, and the word peer is chosen quite well because it is a peer-to-peer connection, and both elements within the WebRTC connection, browser A to browser B, are actually quite equal. We'll see some of that later. You create it with all these lovely parameters. You can generally ignore them, you just know you have to put them in. Stun server, as you may have seen from some of the talks previously, is a little server that sits somewhere out there in internet land that says, you may be your own local PC, but to the rest of the internet, you have this IP address. This is your external IP address. That's what the stun server gives you. It's quite simple, it's quite small, which means you can find these for free pretty much everywhere. The turn server is something that takes a media stream, turns it around, and sends it down to someone else. That's a media stream. That's a lot of data, that's expensive, that's not free. But there are free pieces of software, such as CoTurn, which allows you to run your own turn server. So nothing too difficult there, just fire up your favorite server and run your turn software on there. Stun, use Google's or anyone else you fancy, and call peer connection. Everything else will go through peer connection. Add the stream in that we just got previously, and that tells the peer connection this is what you're sending. We then agree on what they're going to communicate. And at this point, we start the first part of the live demo. Everyone holding thumbs. So the first few steps we've already seen. Get user media. We make the call. This is exactly the same call as what we saw on the slides. It's the same code that's running in the browser now. And there you can see me. That's proving it. And this, look, I'm holding up fingers. It proves that it's not recorded. I create that peer connection. Those are the parameters I showed you earlier. I'll talk through these bits later. You'll see something magic happen there shortly. I then add that media stream to that peer connection. Done. It returned true. Success. So far, so good. I should probably quit while I'm ahead. Thank you. Good night. So, back to the slides. Next, we agree on what the two browsers are going to communicate. We know it's going to be something audio-video-like. We've got a media stream. We'll worry about that later. And we come back to constraints again. I said peer was important. They are actually quite equal. So you can say, hey, I've got a video stream I want to send you. And the other half says, yes, I accept video stream. Or the other half might say, no, I'm in the shower. There's no way I want to accept a video stream in this state. You pass them through, you create an offer. This is just something that the WebRTC code does for you, and it says, I offer you the chance to get this video stream or this audio stream. And it creates a big long string describing what that offer is. The other side then receives that offer and gives you an answer back, which is created thusly. We'll show that now for reals. So we come here. We'll create an offer, which is called the SDP. I'll scroll back that. And this is the offer. It starts here with type offer. It then says the offer type is of an SDP. Fair enough, that's the session description. And then there is this string. I'm going to scroll through it slowly because there will be questions at the end. That's a 0, by the way, not an O if you're making notes, okay? There we go. Simple enough? Jolly good. That's the offer, which you then have to send to the other side. I, as the person sending this video, offer you this. You then send it to the other side. This is the science bit, as Jennifer Aniston, sorry, the signaling bit, as Jennifer Aniston probably never said. This is the bit you need to send from browser A to browser B. The signaling bit, as is well documented, is not available in the WebRTC spec because it was purposely not put in there. So for the purpose of this demo, I shall be using the signaling protocol known as copy and paste. I've copied that into my buffer. I will go to another window in the same browser. I shall do get user media again. Hello, that's me. I shall create a peer connection again. I shall attach that media stream to that peer connection, same as we did on the other side. Both browsers do the same thing. The receiving browser now gets that SDP, copied and pasted. We then create an object, which is the session description object, with that text string, and then apply that into our peer connection. That's 2 steps to do one thing. It takes that big long squiggly string, creates an object, and then sets it. That's 2 operations. For the simple reason, that long big squiggly string, which is the technical name for it by the way, that big long string might want to be manipulated. You as a developer might think, I don't agree with this little bit in the middle. I think it should be something else. You as the developer have the option of changing it, which is why it's in these 2 stages, these 2 stages like that. Once the browser B, the person that's receiving this call, has taken that offer, it gets to answer and says, thank you for your video. I accept your video. I now give you the chance to have my video. So it creates an answer. And the answer is like this. And you can see it starts here. Type answer. And it contains pretty much exactly the same thing as the offer. Why should it be any different? They're both exchanging media. They're both peers, so they're at the same level. There's no master-slave, you must do this. So it stands to reason that they are going to be fairly similar. And if you were to go to the slides, you'll see that when I wrote the slides, receive answer and receive offer use exactly the same code because they're doing exactly the same thing. So we create that SDP of an offer, of an answer. We apply that answer back to the local description. So even though the local WebRTC API has created the offer and given us this text string, it still requires us to set it back and tell the peer connection, this is the one I want to use. For exactly the same reason that it might create the answer for you, but you as a programmer might decide you want to change some of it. So it gives you the chance to change some of this text string before you set it to the local description. You then get to send that answer back to browser A, again, the signaling bit. And when we receive the answer, it does what it did on the other side. It creates an object and then gets set to the remote description. Again, two operations for the same reason. You might want to change it. Just because the other half says, this is the answer you should be using, doesn't mean it's the answer that you have to use. Now, certain other bits of magic have happened off the top of the screen. These things. When these SDPs happen, it's got a lot of information there about what that machine is, where it is on the network, and what it's doing. And this comes to the part of how is it going to communicate. And this is where the ICE candidates come in. Now, ICE is Internet Connection Established or something like that. It's got far too many syllables for me to remember. It's why it's called ICE. There is a thing, I don't know, mid-lecture activity. This is something my lecturers always used to do. You go to the other side of the stage, so you get a different perspective, and use something entirely unrelated to that. But there's this old, all these acronyms solve the problem of things are far too long to even be bothered with. Does anyone still say www dot for things? W is 3 syllables. If you want to say something quickly, you don't choose W, because it's too cumbersome, which means you'd never put 3 W's together, 9 syllables. That's far too complex. 3 syllables, far too much. I'm glad no one in computing does 3-syllable things anymore, except for Alexa, obviously. There we go, mid-lecture thing over. Right, where was I? How they communicate. So ICE candidates. How are these two machines going to communicate? Well, they're on a network. So they might be on the local network, at which point they can say, hey, I'm on this local network. It goes, funny enough, I'm also on that local network. Hey, this is going to be easy. Or they might say, hey, I'm on a local network, but I'm also got an external IP that's quite public. It's like, hey, funny enough, so have I. We can communicate via the big wide internet and still have a nice clear traffic flow. Or they might say, hey, I'm behind a firewall and I can't see anything. So we might have to go to a turn server and then back again. It goes, yeah, so will we. So there's these 3 ways by which they could communicate. So the system, the WebRTC API, creates a series of these ICE candidates, give you an idea of where it is on the network. This one dragged from my home network happens to be on the 192.168 subrange. And if 2 things happen to be on that same subrange, it goes, yeah, great, fine. The security conscious of you will also be aware that it takes no security credentials to fire up WebRTC on the client, which means you can stick this into a web page and grab all the local information on the person's local network without them knowing about it. I'm sure that can be used for nefarious purposes. So let's create some ICE candidates, but the reality is we don't need to. The peer connection already knows it's going to need some ICE candidates. So as soon as the SDP comes in, it goes, hey, I know some of these addresses, I know what I can do with these. So it creates this list of ICE candidates. And you can see from things up here that I've got some VM stuff running on my box, and this is the IP of the hotel's Wi-Fi. So let me take those ICE candidates and send them via the signaling protocol of copy and paste to the other side. At the moment, these are the only ICE candidates the browser B, the receiver, knows about. That's fine, that's fair enough. But we'll give it some more ICE candidates. And it's added them in. Now, by all rights, both sides should send each side its ICE candidates. But the reality is, once browser A can talk to browser B and knows where it is, because they're both in different browsers behind something else entirely, browser B, by default, knows where browser A is, because it's just got a message from browser A. So a lot of the time, browser B doesn't need to send its ICE candidates back, which can be shown here. This is the first get user media I called. This is on the receiving end, and that's my video of me receiving. And down here, when I was creating the ICE candidates, is what I've been sending. That's from the other side. Same thing, but names reversed. This is what the sender created from get user media. And this is what it's received from the other side. That is what's known in the trade as very lucky live demo. Yay, yes. Hey, I'm more impressed than you lot are, don't worry. Not doing the applause cue. And all we did is we said, right, here's the text string of ICE candidates, because everything is a text string. Even that SDP answer, even that SDP query response, it was a mess of text, but it was still text. Meaning any bog standard HTTP request going to any server that you deem to set up is able of doing that. Both browsers are then able to agree to how they communicate, because both browsers are equal, they're both peers, they both look at what they're doing and says, oh yeah, this is your local IP range. Also happens to be my local IP range. There's a reasonably good chance we're on the same network. There might not be, it might be that two people in different companies happen to have the same local IP range, which is reasonably likely. But as soon as they start talking to one another, they'll suddenly realize, oh, you don't have a peer connection open. Well, nor do you. Oh, well, obviously not local company then. So they'll each try these ways of communicating with the other side. And then as we've seen, the media streams flow, and that's it. I did do a demo once where I actually typed in those instructions. And it works. We've built Skype in significantly less than an afternoon. This is easy. I don't know why Microsoft have so much trouble with Skype myself. So there's a few other bits of functionality which are hiding in WebRTC that come in kind of useful. Various stats and data channels. So looking briefly at it, media stats, if you're using Chrome, which most people seem to for developing this stuff, there is a URL where you can see lots of nice pretty graphs, or there is the getStats method, which gets you a lot of machine readable stuff that you can then either use with the user and saying, oh, by the way, your jitter's going up, you might lose quality in a moment, or you can take and send back to your server saying, oh, by the way, that user's logged on again, they're getting jitter again, there's something wrong with that account. You know, if you get, you might get a complaint from them in the future because they get a lot of this stuff. These are the graphs. These are the same graphs that you could generate from the getStats data. There's nothing secret going on here. All this stuff is available through the getStats API. The data channel. Now you get one data channel with WebRTC, and that's more than you ever need because you can create virtual named channels within it. They're not really virtuous. Like if you're already sending video and audio data down the stream, you could send as many hello worlds and URLs of cat pics as you like. It's really not going to break the bandwidth. So it creates one data channel, technically two, reliable and unreliable, through TCP and UDP. And you can send strings and blobs and array buffers or anything else you like down that in any name channels you like. So you could create an unreliable channel. If you're in a game, for example, you could send the XY coordinates of each player as unreliable. Because if they don't get the XY, it doesn't matter. There'll be another packet along in a fraction of a second, so the player will update correctly. And then you can use a reliable data channel to say, okay, this is the new score. This player's just been killed. This is someone's picked up this object, so this object must disappear from the game world. All that stuff has to get there because it affects the gameplay in a much more important way. So you send it reliably and on a separate named channel. The last point is only for people who are really old. WebSockets uses exactly the same API, exactly the same format for all of its data. It's where the API came from. So if you want to move from WebSockets to WebRTC data channels, it's just basically changing the name. There's nothing too complex there. So in conclusion, peer connection is completely and utterly fundamental. Everything goes with that peer connection. You create it at the start, where you give it the turn and sun servers, and everything just follows from that. The order of that stuff is incredibly strict. Anything that goes slightly, if you try sending an answer and you haven't got the request hasn't been received, or you think you've got it but your callback didn't fire in the right place, it will just blow up and you won't be able to recover. You've got to tear down the peer connection, start again. There's other gems such as the data channels and that, which are hiding. They're quite fun. They're quite good. And since we've got some time, I shall open to questions, but I do have another bit which I can follow from if the question that I want doesn't come up. Don't be worried about that. Yes, Tim.
So, so what I just want to say before we go into questions, how petrified I was at the depth of the level of demo you were going to do, and you got away with it. It worked. So I think that was amazingly impressive, and I think that deserves a round of applause as it goes. I mean, I do dangerous demos for a living, and that was dangerous. Right, so questions? We're looking for a specific question. I don't know what it is, so you're going to have to help me here.
Hi, so I work for Google and work on the Chrome browser. So what I'm interested in is like what are the common missteps that you see developers making in this basic process of setting up a connection? What are
So the basic missteps in this basic process is just not picking up errors and the basic state of the system. There's lots of little bits there, you know, the setting, the taking. It's not really that difficult. And there are so many people out there who've created this type of thing that you can take what I've written there, it's all on GitHub, you can take that, copy and paste it, and you won't make mistakes. Where you'll make mistakes is if there's an error that comes along and says, oh, by the way, I couldn't create that peer connection this time, it just happened to fail here for some reason. If you don't pick that up, then handle the error cases, you'll go, well, why didn't it work? You'll hit refresh, it will work that time, and everything will be fine. There is other problems people have outside of the basic demo that I've shown you, which if there are no other questions, I will jump into.
Yeah, sure, go ahead. If there's no one else.
Okay.
So just before we do that, there's one little minor update which has been kicking around in the WebRTC forums around the IP address issue that you were mentioning of like displaying your external IP address or your private IP addresses. It turns out that there are a couple of security changes that have kicked in the last month or so, and that actually doesn't happen. You don't reveal your public IP address unless you are A, running from a secure web page from a HTTPS certificate, and you also have allowed access to your camera on the basis that if you're going to show them what you look like and what your room looks like, your IP address is probably the last secret you're worried about. So there's a slight, and weirdly the browsers implement that very slightly differently, but so that ugly hole is nearly closed. But sorry, update. So on to how things go next.
Yeah, so this I was not intending to do as a bit. I was kind of hoping to save this for next year, because basically I want to come back and I want to make sure there's another one of these. So I'll do an incredibly quick version of a talk that I gave last year at somewhere else, can't remember where, of the problems not with that demo that I showed, but the problems with building it that people have. And it's not problems that people have building the simple version, it's the problem people have of finishing the simple version. It's very easy to start a WebRTC thing. Anyone can do it. If I can, anyone can, as they say. But not many people can finish it. So in the next 14 minutes and 1 second, I'm going to see if I can get through this hour talk. You ready? Okay, so we're going to go through the API, the browser, and the infrastructure, all the things which will and can cause problems in the bigger picture of WebRTC. The first part is the conformity of the API. So what do I mean by that? Well, you saw in the example I called WebKit Get User Media. Funnily enough, that only works on WebKit, doesn't work on all the other browsers, so you have to call Get User Media Proper. Unfortunately, Get User Media Proper varies ever so slightly between all of the browsers. They're trying to conform it and get it right, and some of them have got it right. Unfortunately, there's still some issues. So you start every piece of code saying, well, use User Media Proper, but if WebKit exists, you might want to use that, or the Mozilla version, or the Microsoft version. Then we can call that for proper, because that'll be fine. So whatever browser people are using, it's going to just work. And you have to repeat this same trick for peer connection, ICE candidate, session description, and even URL, because each browser has its own version, all moderately slightly different and slightly broken to everybody else's. So once you've done that, you do constraints saying, I want large video, I want small video, I want audio, I don't want it. Unless you happen to have a browser running Firefox 37, then they're all different and you've got to change them. So you need a little method that just changes all the constraints of the parameter fits. The way you can do that is just by writing your own, or just use Adapter.js. Adapter.js is great, it fixes all these things. Unfortunately, it's never quite up to date for what you want, so you end up having to go and fix it yourself manually anyway. Doesn't matter, move on. So the functionality that you need is probably available in all of them. Get sources is very easy. Get stats is also very easy, except on some browsers where you have to go result and for each, and other browsers you just go for each to iterate through each of the stats. That's incredibly simple. It's only 2 lines of code. The trick is knowing which 2 lines of code you need. Then, of course, there's bugs, because no one writes code with bugs anymore, do they? No. That's the sole problem. Software engineering is fantastically easy. So this sort of stuff actually has a bug in it, but we won't worry about that just yet. So browsers part 1, what version of the browser are you needing? What version of the browser do you need to support? Well, that's up to you and your actual topic base. You know, if you're anchoring one side and you're saying, well, it's a room where we've got a whole bunch of people and they're sat at their PCs, that's fine. You can require them to have a version of the browser that's compatible. Your end customer might not have a version, and you then have to check for that particular version on the client. This image is probably slightly old now because it's a year old, but the URL should still be running, telling you what functions are available, what features are available in which browsers. And can I use, gives the same information just in a slightly different pretty form. Interoperability. All of my testing, generally for most part, is done Chrome to Chrome, because I really hate having to fire up Firefox, but you will have to because your end users probably will have Firefox. At which point you have to worry about, well, do the media codecs that each of these browsers have support each other? Do you have a common media codec? The SDP format, is it going to be slightly different? Are they screwed it up somewhere? Answer is probably they have. Is the functionality that you want on one side the same as the other? We saw the chart previously. Both sides have to have the functionality you've agreed on, otherwise you need some kind of fallback. If you're using old phone-based browsers, there's an option to disable it. Obviously, disable is the default in certain old phones, and if you're expecting people to use their phones as part of your product, then it might be disabled. You just have to make sure you're checking for that, or more importantly, you have to know that you're having to check for that. Then you come to the infrastructure. Everyone's got to build the infrastructure. As we said, signaling is not provided by WebRTC, so you have to provide some way of providing signaling. You've got to find some way of user discovery. Browser A is going to talk to browser B. Fine, easy. We have not said who is browser A. You've got to log on to in browser A to say, hey, I'm Steve, I want to chat with Bob. Bob, you've got to log on. You've got to have that built. You've got to have your turn server, because no one's going to provide one for free because they take up so much bandwidth. If you want to do recording or transcoding, because you're storing all this stuff for later processing by Cambridge Analytica or someone, you've got to build that into your system. If you're going to be using mobile, you've got to make sure you can handle mobile. The smaller screen might have an issue for you, or the lower bandwidth might be an issue. And apparently you have to do testing on this stuff. I don't know who tests their code, but apparently it's a good thing to do. Business logic, obviously it's not going to be covered here. Everyone's got their own business, but you've still got to write that. Is it many users answering a call? This is call center world. One person calls in, up to 20 people could answer that. You've still got to build that. You've still got the same problems. Every single person that logs in must have the user discovery in there. Injecting messages calls into the stream. Someone calls up your call center. All our operators are busy right now, but your call is really important to us, but not important enough that we hire enough people to answer your call, but your call is still important to us. That piece of speech has to be recorded and has to be injected somewhere into the stream. You've got to build that. You've got to know how to build that. That's something else you've got to do. Billing, one of the bigger things that people, especially in the commercial space, are interested in. It's not the tech, it's how are you billing for this? If you're billing by the minute, you've got to know when that call starts, when it ends. If there's dropouts, if there's jitter, you've got to be able to track that to know, well, did it drop out enough that we should probably cut their bill down a bit because they won't get too annoyed? You've got to scale the platform. One-to-one call, fine. But if it's going to be multiple people, that's going to require more bandwidth. If you're expecting to have 1 million users on there every week, you need to have some way of scaling that. That's not an AWS instance that you can just spin up. You've got to have some infrastructure to help you spin up all these different things and keep your user discovery and your signaling working across all those things. Fault detection, again, if something fails between browser A and browser B, at what point in the chain has it failed? Is it their end because they're running a stupid old browser that you don't support and you didn't realize you don't support? Is it that user's firewall? Is there something between them and their ISP? Is it the internet at large? Is it browser B's ISP, browser B's firewall, or browser B's oldness, or something else? All this stuff's got to be fault checked and worked out. So say, by the way, it's user A's fault right now. And also, by the way, I thought I'd try and be clever and just do all these extra little bits, at least some of these extra bits. So I wrote 1,809 lines of JavaScript. Nothing much really, it's kind of the day job. And because I fancied a challenge, I thought, let's see if I can still write PHP. So I've got 1,800 lines of JavaScript in the browser to do this connection thing and all the WebRTC goodness. I've got 1,500 lines of PHP running on a server to handle some user login stuff and some session protocol transmissions and all this kind of stuff. And some custom JavaScript as well for just the app of, would you like to connect to browser B now? Only 437 lines. That's quite straightforward. But that was only for one call. So although WebRTC gives you the really complex stuff of voice and audio communication stuff, you've still got a few thousand lines of code you yourself have to write to do something that is supposedly available for free in the browser without plugins. And that only works if everyone does everything right, because I didn't do any error fixing in this stuff. If there's an error, it just puts up an error and says hit F5 and refresh and have another go. So my conclusion from that is there's not that anything that's missing from the WebRTC API. It's there, it does the thing. It does the thing which is complex, the thing that I don't want to code. I did build a video chat thing in '96, I think. It was horrible. It was blocky, it was slow, it was mostly broken, but it kind of worked and it was good enough for the time. Now that's not good enough. The fact that everyone on their phone can have a video chat with someone on the other side of the world is what people expect. So if your application is not that good, all of a sudden you're 2 rungs down. But there is a lot more to do than what you are told in the advertising brochure for WebRTC. And the old pithy one-liner, if you want to tweet stuff that's nice and pithy and conference-like, it's easy to build something, it's much harder to finish it, which I have done in about 10 minutes. That obviously means I oversold my FOSDEM talk last year. So I shall jump back to that one. So that entire other thing, that comes back to the small demo was shown. People generally don't have a problem with that. They can generally build that, they can get it working, they can show their boss, they can say, look at me, aren't I clever, give us a pay rise. But then when it comes to deploying it for real in the real world, all of those problems suddenly rear up. And that's where people have the problems.
So let's see if there's another question or two around those sorts of rapid, high-speed difficulties. So, yeah, more questions. You all going to build Skype this afternoon then, obviously. Okay, well, in that case, I'm going to thank Steve for his energy and enthusiasm and the risks he's taken in doing this. So, brilliant. Big round of applause, please. So we now have a 30-minute coffee break. Back here at 11 for Hub, who's going to speak about